In the previous videos on the UK's historical water development path, we've seen multiple, expensive investments have been made over time. This echoes one of the key points we made right at the start of this course. Water is a huge societal enterprise, and pipe networks in particular are capital intensive. We've also suggested up to this point this week that more investment will be needed in the future. The UK system is not finished or complete. In a moment we're going to see this concretely. In fact, you might be quite surprised at the continuing scale of investment that we're going to see. First, I'm going to show you capital expenditure data for the England and Wales water and sewerage companies. This will cover a fairly long period from 1921 to 2015. It'll be a trace, a kind of evidence trail of this recent part of the UK's overall water development path. I would like to show you data from the 19th century, given that we spent so much of this week talking about that period of the UK's history, the Victorian era. Sadly, the data needed to do this is not readily available or disaggregated sufficiently to help us. Second, we'll also look at cost data over a shorter period, from 2005 to 2009. We'll do this because it gives us a rarely seen breakdown of total costs. Like we emphasised in week 3 when we looked at the 7 components of total cost, here we'll be able to see what proportion of total costs capital expenditure has accounted for. We'll see it as a portion of average UK household annual water bills over time. I've drawn this graph from data made available by the economic regulator of the England and Wales water sector, Ofwat. It shows the annual capital expenditures, or CapEx as it's often known in the UK, of the major England and Wales water and sewerage companies. That's the 10 large privatised utilities that I mentioned in the previous video. Until recently, this data had not been that widely seen in the UK or elsewhere. Part of it has now been printed in recent independent reviews of the UK water sector. The data was first given to me by a member of the staff of the Environment Agency, and I've been updating and working with it since. I want to say a few things about this data. First, if you add up the capital expenditure over the time period here, you get about 220 billion British pounds invested over the 94-year period from 1921 to 2015. That's in constant 2011 prices. This graph here has some estimates for the 2011 to 2015 data, so the actual amount might be slightly different. Nevertheless, if we go with the 220 billion pounds figure, we see that just over 115 billion of that, that's more than half the total amount, was invested just between 1989 and 2015. In other words, since the privatisation of the England and Wales water sector. So over a half of the capital investment has been made during about 1/5 of the time period shown here. This is remarkable, regardless of one's stance on privatisation of water utility services. Second, we can see that the spending trend is upward. That's the grey line here, showing CapEx in billions of British pounds per year. And the spending has more or less stabilised or levelled off since privatisation. We can, however, see here the impact of capital expenditure activity of the England and Wales privatised water industry working to 5 yearly programmes of investment since privatisation. Can you see the 5-year period spikes on the right-hand side of the graph that show this? The black squares and partial trend black line here show the capital expenditure per capita to correct for the changing, growing population of England and Wales over this period. To make it more obvious what's happening with this CapEx per capita measure, I've drawn 2 lines through the data here. The blue line is a moving average, the red is a linear trend. We can see that successively more capital per person has been spent over time. The trend is clearly upward. One might see this as a good thing or a bad thing depending on one's point of view, and depending on whether the trend continues to be upward into the future. It essentially means it's costing more capital per person to deliver these water and sewerage services over time. From our look at the UK's water development path, we can suggest why this might be the case. The system has been successively upgraded over time, in part to deliver higher water, wastewater and environmental quality standards. Assuming there were about 23 million households in England and Wales in 2008, and taking about a 5 billion British pounds figure for CapEx that year, gives us a figure of nearly 220 British pounds invested per household. Taking an England and Wales population estimate for 2008 of about 54.5 million people, that's about 92 British pounds per capita per year, and this is the level you can see in the right-hand side of this graph. Returning to the Hopi case we looked at earlier in the course, the £220 per household annual figure here, expressed as a monthly per household cost, would be about £18 per household per month, just on capital expenditure. Exchange rates varied a lot in 2008 due to the global recession, but let's assume that £18 comes out at about $35 per household per month for capital spend in England and Wales at this time. That's significantly cheaper than the over $280 per household per month we saw to deliver pipe services to the Hopi. Remember here, though, that the England and Wales figure only includes the capital. Generally, this graph tells us nothing about non-capital costs, such as operation and maintenance costs, or operational expenditure, or OPEX as I typically refer to it. We do know that OPEX for England and Wales has been in the range of £3.1 to £3.8 billion over the period 1989 to 2015 in constant prices, according to Ofwat data. Taking that into account would bring us closer to $60 or $70 per household per month for the England and Wales case. We'll see a more precise breakdown of the different cost components over time of this in a moment. Note also, though, that this capital expenditure plot, as well as not telling us anything about OPEX, also can't tell us about the relationships between operational or OPEX and capital or CAPEX spend. This is important to realise because there are a number of ways that the two can be related, depending on what incentives are present in the regulatory system. For instance, one can underspend on OPEX, perhaps gradually running down the network, to eventually require capital for asset rehabilitation or replacement. This is known as sweating the assets. This might happen where incentives provide better returns for capital expenditure as opposed to operation and maintenance spending. This potential for a so-called CAPEX bias has been looked at by Ofwat and others in the UK. There's another factor here that I'd like to draw your attention to. Economic growth, or growth in gross domestic product or GDP, occurred for England and Wales during the 1921 to 2015 period shown here. I've now adjusted the graph as you see it here so that the black squares and partial trend line in black now show the CAPEX per capita divided by the GDP per capita, or put another way, the CAPEX over GDP. Now I've added the same colour lines as before. Blue again is a moving average line, red is the linear trend. This shows us at least two things. First, we can determine the water and sewerage capital spend as a percentage of GDP over time. It's about 0.3% throughout the period. Correcting for GDP growth, the previous apparent upward trend in spending disappears. Second, the level of capital spend adjusted in this way appears to be a fairly fixed component of societal activity for this England and Wales case. It seems a relatively constant cost that has not gone away or substantially reduced over time. What implications for future planning for the system do you think this suggests? In this next slide, we can see a breakdown of costs, among which the capital expenditure charge we've just seen is only one element out of four. This data comes from Ofwat again, and it was presented in this way in the 2009 Walker Review here. This was an independent review of charging for household water and sewerage services. It is important, but it's not typical to see this kind of cost breakdown. Here we can see, starting from the bottom of these bars, how much an average England and Wales annual household water bill breaks down into an operating cost, or OPEX, a capital charge, taxation, interest on borrowing, and profit. We can see a ratio of OPEX to CAPEX of about 50 to 50. This is not very different to the typical figures we've seen already in this course. Notice, though, that this data, interesting though it is, still does not tell us everything we need to know about whether the system is operating at full cost recovery, in the way that the England and Wales privatised water industry is typically presented to be. For instance, there's another interesting fact that was highlighted in the 2009 Walker Review report from where I've taken this plot. That was that while most CAPEX years depreciated over about 50 years, the Victorian 19th century brick sewers that we've seen in the previous videos for this week are depreciated instead over about 800 years. This is apparently to account for the massive cost of replacing them. It seems that it's been done not so much to reflect the expected life of these Victorian assets, but rather to arrive at current annual household water bills that are acceptable to politicians, regulators, customers, and other stakeholders. This brings us now to the end of our example water development path taken from the UK case. I think some of the main points we can take away from this overview of hundreds of years of UK water supply and sanitation system history are quite well captured in this quote from Johnston and Horan. They here highlight that current water and sewerage system standards in industrialised countries like the UK have been the result of a long period of investment in infrastructure projects. We've seen that's very true for the UK case. Johnston and Horan also illustrate their point with the story of the River Thames cleanup case that we've seen in the videos so far this week. They note the succession of technical, legal and institutional developments that go alongside monetary investments and application of increasing quality standards. We've encapsulated this idea as a sequence of decisions and investment choices that have been made within a long water development path for the UK. Based on all this, we'd like to leave you with an optional exercise that we think you might like to try. This returns to the water development paths exercise that you tried at the start of this week for a rural Africa case. Now we're going to ask you to use it as a tool to think about the future UK water development path. We've marked here that the UK starts from more or less full coverage of piped water and piped sewers. But where might it go from here? We've actually recently used this exact water development paths template that you see here in a forward-looking way with senior water utility company staff, and we've been quite surprised by what they've come up with. We can share a bit about that through our teaching assistants on the discussion forums. But where do you think the UK should go? And what sequence of steps should it take to get there? You may think about using this development paths tool, adapted to your own situation, to think about water development paths in your own country too. Once again, do feel free to discuss whatever you come up with on the forums. Before closing, I'd also like to remind you to watch the other videos for this week. In particular, do try to watch our final wrap-up video for the end of this 6-week MOOC. Thanks for watching this video.